Okay, so now we'll go ahead and take a look at the snow squall environment and see if it is favorable and if also we expect that one may start occurring if it hasn't already occurred yet. So let's take a look at the contributing members to the snow squall parameter. Then we'll see how well it agrees with the actual snow squall parameter. And then see if the forcing mechanisms, especially the primary forcing mechanism for precipitation, coincides with positive values of snow squall parameter. So we'll start off looking at the top left panel. And up here, we have the 0 to 2 kilometer mean RH and winds. So the mean RH, anywhere you see greater than 80% is colored in blue. And indeed, along the front, in fact, you can see the theta E. We have the 1 kilometer theta E as well. And you can see the front right here. And you can see that it's humid. It's 0 to 2 kilometer mean RH, greater than 80% along and north of the front. And also in this area, we have winds of at least 40 knots across most of this region. So those two parameters kind of match. Let's take a look at theta E difference. And here it is looking around the same time. We look at these values and we have the GOES 16 air mass RGB in the background. And you can see the air mass RGB shows lots of low to mid-altitude clouds in this region on the tail end of the shortwave. And in these regions, we also have theta E difference between 0 and 2 kilometers, less than 0 degrees, which indicates convective instability, lapse rates exceeding moist adiabats in this region here. So that matches as well. So the question is let's take a look at here. This is the one where we're going to actually see how these regions coincide. Do we have positive values of snow squall parameter? But before we do that, take a look at the isobaric gradient here. That's what I plotted, 1 hour pressure change. And you can see the gradient where we have rapidly increasing pressures just north of the front, and on the south side we certainly have an isobaric gradient, a feature that's common with snow squalls. So let's go ahead and hit this snow squall parameter, and sure enough we do have values in excess of 0, most of them in excess of 1 across most of northern half of Wyoming, especially in the northeastern half. So that matches as well. So the only thing left to look at is to take a look and see if this region of favorable snow squall parameter coincides with precipitation forcing. And of course, the number one mechanism for that is frontogenesis. And indeed, as I drag my arrow across the region of frontogenesis max in the lower right panel, you can see the cursor going across regions of favorable snow squall parameters. So we have everything right here. We definitely have the background environment set and ready. Precip forcing. You've seen already we've got that snow band. Essentially, we have the markers, and we're just waiting to see if the visibility reaches below the quarter mile.